Hello, and today I'm going to be showing you a little project I've been working on for a little while. It's basically an upgrade to my older version of a subtraction machine, which you can see as well in my older videos. It was a lot taller, my older version, but this generally goes with the same exact premise. So I'm gonna spare you watching that video. But yeah, let me get to the first part to begin with. So first thing we have here is our subtraction machine, which, like in the first video, there were two subtraction machines and one greater than or equal to machine on top. Well, actually, a general version was on the bottom, but yeah, still. I put it on top this time just because it actually makes things a lot easier. So, actually, might make it hard. I might experiment with doing it on bottom now. So anyways, let's just get into this. So, first things first, let me just explain to you how this works. So, okay. First thing that goes on here is we have a little comparing thing. Now okay. So the first thing we're going to do is this machine on its own actually works, but it only works with numbers where the positive number is greater than the negative number. So let's say, for example, you have, I'm going to use the exact same number, 5 and 7. 5 in binary would be that, and positive, I think I used positive 5, yeah. Negative 7, so negative 7, positive 5, just exact same thing. So, yeah, currently we have negative 7 plus positive 5, or 5 minus 7 now. The thing right here, it's showing it as basically being 0, but that's because what this would actually be doing after this would be inverting it. I just copied this part from the middle section of that, so it doesn't do that. Realistically, this should be 1, 1, 1, 1, 1, 1, just a lot of ones, just infinite ones. And that's the flaw with this system. It doesn't know how to do negatives properly. The system I'm about to show you actually does understand how to do negatives, but first I'm going to explain to you how this works. So, generally, the premise I originally had was, hey, I explained this in another video. If you have if you like revert it, so like 5 minus 7 becomes 7 minus 5, you get 2. You put a negative symbol before that, it's negative 2. Now 5 minus 7 already equals negative 2, so that's the exact same answer. And this works for basically making negative numbers even using this system. So what I'm doing here is, in this part, is I'm making two of these systems, which I'll explain to you in a bit. I'm having two of them. One of them uses the regular numbers, one of them uses the inverted numbers, and the thing on top says, hey, which number is greater? So it says which number is greater, 5 or 7. It might be simple for us, but it's actually pretty painful for this to do. Well, not too painful. So let's get 5 and 7. So in this case, yeah, it's showing up as a negative number. I believe it should be showing up as negative. Yeah, negative. So yeah, it's showing up as a negative number. Let's see. Yeah. So what this top section does, I'll just explain this top section first. This compares two numbers, so it says which one's greater. Now, how it does this is, first of all, it cancels out the numbers if they're both the same. So, which one's greater, 10 or 10? Well, let's just immediately know to cancel 10s out because, you know, there's already a 10 there. Goodbye. But if one of them splits through, let's say it's in this case, a 10 or 0, then it's gonna be like, hey, no 10 on this side. It's gonna just go right through here. So what's happening here is, basically, it's just canceling it out. So let's say they're both active. No, let's just look at this. What's happening is it's sending a signal through here. The signal strength gets sent down to 14 because, you know, that's how redstone works. It just goes down every wire. And this comparator is on subtract mode. So what happens here is, as you can see, it's on subtract mode, powered true, facing, etc. It doesn't matter anything else. Just matters is it's on subtract mode. And now all the ones I have on subtract mode need to be on subtract mode. You have to have all of these comparators on this part in subtract mode. There might have been like one, oh, random cave noise, nah. There might have been one or two in this section, I forget, that don't need to be on compare mode, but generally everything can be on compare mode, and it's better on compare mode. So anyways, what's happening here is it's sending a signal through here. This becomes a signal strength of 1 because 15 minus 14 equals 1, obviously, so power equals 1, and that's enough to send a signal through here, which cancels this. So what's happening is, if both of them are on, no signal. If neither of them are on, no signal. If one of them is on, there's going to be a signal somewhere. It's basically an XOR gate, except it has two different paths it can go through. Which actually there is an XOR gate in the subtraction machine right at the end. But let's see. So next part. Let's say this one. Hold on. Wait, no, that was on. What am I doing? So it's sending a signal through here. Now, when it sends a signal through here, it goes into these two repeaters going into the comparator, which has to be on subtract mode, and into this wire, which is detected by the repeater, sends to these three wires. Now, when it sends it to these two wires, it goes to these two repeaters and sends a signal to this redstone wire, which disables the comparator. Now, what this does is, let's say we have, thinking this one. It's sending a signal through here. Now, if this weren't here, it would send a signal to its comparator and be perfectly fine. But because it's on subtract mode, it should have to be, and it's sending a signal through here, it's entirely disabled. So what it's doing is basically saying, hey, anything below this does not count. So let's say you have you're comparing a 10 in binary and a 1 in binary. 10's obviously greater than 1, but what it needs to know that is, it needs to know, hey, it basically is storing, hey, it's always going to be 10 because it's going through this line. Nothing can cancel this line once it's gotten started. Same with this line. So let's let's swap this out. So let's say instead of -7, it's -5, and +7. So it's sending a signal to this repeater. Because it sends a signal to the repeater, even if both of these are even if, let's say, because let's say this one's activated, even though it tries to send a signal here, because this is on subtract mode and it sends a signal, which, okay, so if this one's on, it will not be able to send a signal here. A redstone wire does not send a signal to this one, but it can be detected by the redstone repeater, which is why this needs to be here, because this sends a signal through here to this wire, which is detected right here. If this one's on, it won't send to the wire, which means it won't be detected and won't be cancelled. So that's what it does. Really, it just cancels it, makes this right. So, I mean, that's generally the premise of this this greater than or equal to system. That's really it. So let me show you the subtraction itself. Now, the subtraction machine is a little more complicated, but it's pretty much, well, it's not similar necessarily, but it's got a few aspects copied. So first thing that happens is pretty much the same thing, except you've got this thing instead. So what this does is, if this one's on, it will send a signal here and here, instead of it sending only a signal to here. And if this one's on, it will only send here. It will not send a signal this way. So what this is this is the negative, this is the positive number. So -1, let's do 10. Alright, that's -10. 10 and -1. Now 10 minus 1 equals 1. So what it's doing first of all is sending a negative here, because, well, really it can be, this is the exact same as this thing. The only difference is there's nothing before that, so we can just use it like this. There's no need for this right here. We don't need this system right here if there's not a input right here. But we do need it because there's an input right here. So, let's see. Next thing we have is this. So we have another system, and these are all looping. That's what's great about these. They just are repeated, and I like doing things like this that just repeat infinitely. No differences. It's all the exact same thing, and it works perfectly. So it's sending a signal into this. This basically represents a negative number. This represents a positive or negative. Technically, this could be a negative. So instead of this one, we have this one. It's also putting output. Now, the reason it needs to put an output is, well, let's say you have 1 minus 100 in binary. Well, 100 minus 1 in binary. Sorry, I did the opposite way. 100 minus 1 in binary equals 11. But how is it going to know those 11s? Now, the most efficient way for me to do this is through it to an output right here, if it knows this. Because no matter what, if there's a negative here, it's going to output here, unless there's a negative here. If there's a negative here, it cancels that. That's the only, like, if-else thing here, and that's why it does something right here. So, that's the only problem that can occur, and we fix that problem by putting this here. So, what's happening here is, we've got a redstone torch. Redstone torch inverts the signal. So if this one's unactivated, if this one's deactivated, then it will send a signal through here disabling this redstone torch. Now what this redstone torch allows it to do is, let's say, it'll carry over to the next one. So it'll basically say, it'll basically be representing it as though this one was activated. But it's not the exact same thing. If it was totally acting like that, then this one would be activated and it would just loop around, and yeah, that just doesn't work. So it has to do this, which will disable this redstone torch as long as this. Well, no, it will disable this redstone torch no matter what. But the thing is, if this redstone signal is activated, it will disable the torch. So even if this one is activated, even if this one's deactivated, as long as this one's activated, it will deactivate the torch, because no matter what, if there is a signal going through this one, or this one, the torch will not be able to be activated, because if we have a positive number, there's no real reason we should be doing a negative. That would just be stupid. And if we have a negative number, but we also have a positive number, then, yeah, well, that means there's got to be 0, and there's no reason to go that way. So let's see. Next thing we have is an actual XOR gate. That all it does is just act as an XOR gate. This works because of the inversion, actually. Well, not technically, but yeah. I mean, if one of them is activated, it'll send a signal through here. If both of them are activated, it will not send a signal through here. I mean, technically, we could just like revert it, because we do revert it at one point. I'm going to show you on this system, we do revert it with this like redstone torch right here. This reverts it. So, and we combine the signals before that, which actually saves space. So that's the only reason we don't, I guess, revert it before that. But yeah. Let's see. Yeah. So signal to here, goes to here, there, and loops the process continuously, going forwards, and that's generally the entire process of it. We've got this right here, which is just stuff that was copied over, which is just a little bit extra, which is just the signal being carried over from here to all of these different pistons. Yeah, that's all it does. Technically, jeez, I just figured out a much better way of doing this. I could just use a redstone torch. All of my problems are solved with redstone torches. I mean, oh, and then we have this little bias. Yeah, I think I already told you that, though. I forget. There's this machine we made over here. Oh, this poor thing. This was my original design for the top layer, and I realized I could use a redstone torch to accomplish the exact same effect, and I was just so disheartened because I wasted my poor creation. It's just meaningless now. I mean, anyways, that's generally the entire system explained. You can rebuild this for your own. I'll just do a slow look over it while I'm, yeah. So I guess this is the outro, so if you want to make this your own, feel free to do so. I'm just gonna give you a quick look over it. Anyways, so you can experiment with it on your own. If you have any suggestions on how to make the thing actually better, please put them in the comments below. Other than that, I guess that's all I have to show you here for today. Yeah, feel free to just use any of this, make it better. If there's a better way of doing it, please tell me. That's all I have to show you. Anyways, bye.